let's get started. This is a talk about m2e Eclipse and some of the difficulties we are facing making it work inside, well, Eclipse Workspace, I guess we can put it this way. And so this is an advanced talk, so I expect that you already know what m2e is, how to use it, how to use Maven, so you've set up your Maven builds already, so I don't need to explain any of that. And so very briefly about the goals of m2e project. At very high level, we are trying to make it possible to develop Maven projects inside Eclipse. Right, so we are particularly going after deep integration into Workspace, so we are trying to make full support for incremental Workspace build. And we are also building a framework for execution of extensions, not a monolith solution. So although we do not tell extensions what they should or shouldn't do, we generally recommend using existing Eclipse tools like JDT or WTP, and also delegating to existing Maven plugins whenever it's possible or feasible. But it is always possible to just start and write everything from scratch if you want to. Okay, so the first area I'm going to explain how it works is project import and configuration. But before I do that, I need to remind you that during command line build, everything that happens to the project is fully defined by project build lifecycle. Essentially, a set of Maven plugins that are executed during command line build tell everything what the project does. And there is no other source of information about the project. And because of that, the approach m2e took to decide what to do with the project when it is imported into Workspace is to essentially look at project build lifecycle and map every plugin execution to one of the three actions. And the actions are either, m2e can either ignore the plugin, which is the easiest one. It can delegate to an extension, and it can also execute Maven plugin directly. And so probably I should mention that during command line build, all plugin goals in the build lifecycle are executed sequentially one by one, starting from the beginning and ending to the end. And this is done just one time during command line build. And when m2e imports projects, this is more or less what we do as well. Right, we start from the top and we delegate to all configurators, as we call them. These are extension points that can talk to Eclipse Workspace and Eclipse APIs directly. So whenever we find plugin execution that is mapped to a configurator, we just tell configurator to do its thing. We don't know what it is. We just assume that it does the right thing. And although it isn't, at least it wasn't possible to let Maven plugins to participate in project configuration directly in m2e 1.0, in 1.1 we added a possibility for a Maven plugin to indirectly influence project configuration. So the way it works is that plugins get executed as part of what we call configuration build. And the only thing the plugins are expected to do during this configuration build is they can add additional elements to Maven project model. So for example, if you have a module or Maven plugin that introduces new compiler source routes to the project, they are added to Maven project model, and this is where m2e GDT configurator will find them. And this is how additional source routes will be created in, source folders in GDT terminology will be created for your Workspace project. But during this configuration build, Maven plugins are not expected to create any resources because this will confuse m2e. Okay, so once the projects are imported, m2e will resolve dependencies of all Workspace projects, and it will actually maintain up-to-date resolved set of dependencies for all Workspace projects. And whenever you change a pom.xml file, or either directly or as a result of your Git pull or whatever SCM you're using operation, m2e will automatically recalculate dependencies of all affected projects. So dependencies are always kept up to date. Unfortunately, there is no nice way to implement this or clean way to implement this in using Eclipse APIs. So we have two code paths that deal with when your workspace has automatic build enabled and when it doesn't. But it works quite well. So speaking of dependency resolution, so one of the first features we introduced in m2e that didn't quite match what was happening on command line was what we called workspace dependency resolution. So if you are familiar with PDE, how PDE worked since ever, and how m2e works for maybe 5-7 years now, is that when one workspace project depends on another, so instead of resolving dependency to the artifact produced by the target project, m2e will use project's output folder as dependency. So this works for many existing Maven plugins, but some Maven plugins still they expect to get a jar file as a dependency, and they basically throw an exception that I cannot unzip this directory, for example. Luckily, most of such plugins, they can be ignored safely during workspace build, so they do not really cause any problems. But if you happen to need to use one of those plugins during your workspace build, basically your only option is to convince plugin maintainers to make them support m2e workspace dependency resolution. Attached artifacts. So each Maven project can produce multiple artifacts. There is things like test classes that can be deployed to Maven repositories as part of project build. There is EGB clients, sources, Java dog. The problem with the attached artifact is that there is nothing in Maven project model that m2e can use to determine what those attached artifacts will be or what resources they will include. m2e can make reasonably good guess about main and test artifacts, but we simply don't have anything to say about, for example, EGB client m2e project wants to support. And to make problems worse is that JDT actually doesn't support like fine-grained dependencies on other workspace projects. So your workspace dependency either includes all project outputs folders or none at all. So m2e cannot express dependencies just on test classes produced by other workspace projects or just main classes, right? It will always expose your code to both test and main classes of the dependency project. So another problem here with class path management is that Maven distinguishes main and test dependencies. So effectively, each workspace project has two class paths, one for compiling main classes and another for compiling test classes. And there is simply no way to express this using current JDT APIs. As a result, projects inside m2e workspace will use test class path to compile main classes. So for example, if by accident you include JUnit import into one of your main classes, you will not know about this until you try to run the build on command line. You will get no warnings or errors or anything like that. It will just compile well inside your Eclipse workspace. And we actually brought this up to JDT team last year, and their proposal was to, well, you have two class paths, let's create two workspace projects for the same underlying Maven module. So I'm not convinced this is actually going to work, but from usability point of view, so this was basically not an option for us. We politely declined. Okay, runtime, class path, and source lookup. As you probably know that runtime, class path, dependency resolution rules are like something that are specific to Maven. And GDT, in order to represent them properly in Workspace, m2e provides its own implementation of classpath provider, runtime classpath provider, and source lookup path providers. And so when you do run as Java application or run as JUnit test, what m2e does behind the scenes, it basically hijacks the launch configuration and injects its own classpath providers into the configuration without telling you anything about it. Which isn't nice, but for some reason it works, and we haven't had a single complaint about this, well, since we introduced this feature, I think 4 years ago. We actually had other complaints. So somebody was complaining that m2e didn't inject its configuration classpath providers into test and G launch configurators. So we had some additional hacks, added some additional hacks into our code to also hijack test and G configuration, launch configurations. But unfortunately, there is no nice or clean way to do this. And if you have your own launch configuration types that you need to support, you basically will have to talk to m2e directly to inject proper classpath resolution rules into your launch configurations. Okay, let's keep this for now. All right, so if we go back to this picture, lifecycle mapping diagram, what I forgot to mention is that the same lifecycle mapping m2e uses during project configuration, it also uses during project build. Right? But unlike project configuration, where we have a luxury of being able to execute project configurators in the same order of Maven plugins they correspond to, during the build, the granularity of builders and corresponding Maven plugins is often different. So one of the examples is a Java builder that also always builds both test and main classes. And these two are represented by two separate steps in Maven build. And for AspectJ, for example, and AGDT tools, it's even worse because AGDT Workspace compiler, it takes care, well, at least it used to when I looked at it last time, it takes care of both compilation of Java and AspectJ code. It's the same builder. So I purposely drew this messy diagram to show that this clean sequential build that happens during command line build kind of is kind of mangled when it's mapped to Workspace build. But this doesn't actually cause problems by itself, because the way m2e Workspace works is always driven by resource deltas. And the mechanism Eclipse uses to allow different builders to communicate with each other is through those resource change deltas. So for example, when Java builder makes a change to Workspace resources, those changes are communicated to Maven builder. And likewise, when Maven builder makes changes to Workspace, those are communicated back to Java builder. So the trick there is that single user-initiated action will likely result in at least two Workspace builds. One to deal with initial delta, and the second one to deal with any secondary deltas. And this actually causes troubles, right? And I'm going to show a couple of handmade animations to demonstrate like mechanics, some of the biggest problems that we have noticed in the past, and some advice how to deal with them. So the first problem is endless build. Basically, user makes a change to a file, saves the file, and then m2e keeps building forever. Right? So what happens behind the scene? So let's say we have a project that has some code generation plugin enabled and Java compiler enabled, right? So, and let's say the original change modifies README file in the root file, in the root of the project. But because of the code generation builder is not implemented properly, right? So let's say it wraps Maven a plugin directly and just delegates to it without thinking much. And because code generation for this particular case is very light, so the developer who implemented the Maven plugin didn't bother to deal with detection whether rebuild or regeneration is actually needed or not. The Maven plugin always generates its output regardless whether it needs to or whether there are no changes since the previous build. So code generation builder, it receives the delta, it ignores the delta, it makes the changes to the workspace, right? So on the next step, workspace invokes JDT builder with new delta that includes original changes and the changes made by the code generation builder. And JDT builder generates classes, right? And classes created in the workspace, they trigger the secondary build with the new delta. Right, this new delta is delivered to code generation builder, which ignores the delta and does resort change, code generation again, and the process repeats itself forever. Okay, so another problem that we actually struggled quite a lot with, it was the most voted for bug against m2e Eclipse, the project that we took to Eclipse, right? I still remember the bug number in our Jira, 832. So the problem is that from the user point of view, he makes a change to multiple resources, either through refactoring or through git pull or similar operation on file system. And sometimes some of the generated resources are missing from the output folder. It works in many cases, but sometimes resources just disappear. Extremely difficult to debug, extremely frustrating to the user, and we had something called m2e dance to deal with this, right? So you refresh, you rebuild, you refresh. So it took us a very long time to figure out what was actually happening. And what was happening, what was this? So user makes the change, right? And originally workspace and file system are in sync. So m2e would invoke some resource generation builder, which is another wrapper around a Maven plugin. But instead of telling, making modification through Eclipse Workspace APIs, this builder would go and make changes directly on file system. Right? So essentially what happens after that is that Workspace and file system are out of sync. And when a JDT builder, it hits, it needs to access one of those resources that are out of sync. It detects the problem, but the way it deals with the problem is basically it removes all files from the output folder and just regenerate .class files there without telling anyone outside of JDT build infrastructure that the build was effectively escalated from incremental build to full build. And after that, so file system and workspace may or may not be in sync anymore, right? But the problem is that resource generation builder was never invoked to be able to regenerate the resources. And all this happened because originally resource generation builder did not refresh workspace to reflect changes it made on file system directly. So, so the way to deal with this is that we've defined some APIs and rules that tell what makes Maven plugin compatible with m2e, but the same rules actually apply to any builder that participates in Workspace build. It's not specific to m2e Eclipse. It's just the Workspace itself. So these are the requirements of the Workspace. So builders, they must ignore changes that are unrelated to their inputs, right? So if user edits README file in the root of the project and you're watching for some model file you generate Java classes from, you need to ignore this change. Builders must keep workspace and the file system in sync all the time, right? So even you think that this is a temporary resource that you generate on the target folder, still Eclipse may get confused by resources out of sync and can do strange things at times. And most of existing Maven plugins, yes. Yeah. Okay, so yeah. So the question is, if a feature introduced in Eclipse 3.7 or 3.6 to keep workspace and file system in sync, whether it helps or not. So the answer is it doesn't help, because this is essentially a background job that runs asynchronously, and you have no control over the timing when it happens. And it can happen in the most inappropriate moment. And what's worse, it triggers next build, right? So you can end up with the same problem, even in more severe manifestations of it. Well, because the problem is not in Eclipse. Well, so to solve these problems permanently, we need to redo workspace build infrastructure completely to get rid of all those resource deltas and all that. I didn't feel like wasting my time finding a bug for that. But if we choose to live with resource deltas and builders, then the only other alternative is to make sure that all builders, they correctly modify workspace and correctly react to resource deltas. And we actually introduced an API to help Maven plugins work correctly inside workspace. So that API was introduced as part of m2e 1.0. And it's very late. It's very simple, one single interface that Moji can or should rather use that allows modules access deltas, resource change deltas, and keep workspace in sync with whatever file system changes it makes, the module makes. Okay, so we actually, the current API, it has some problems with deleted input resources. So we started to work on a new version of that API, but it turned out to be a significant effort, so we don't know when it will be ready yet. And so there is another pattern that I also see quite frequently, is that instead of making workspace support part of your module code, right? So for example, it's not always possible because you do not control the sources of the module. So instead of doing that, you can actually wrap module execution into a project configurator that unfortunately will have to know details of how the module is configured, right? What resources the module monitors as input or expects as input, and what class resources it generates. But it is possible to do a fairly decent job by wrapping the module and do m2e specific work in Eclipse and then delegate to Maven to do the rest. Okay, so we have just a couple of minutes left. So nested project support. There is no proper nested project support in Eclipse, right? So whenever you try to map non-trivial Maven project into workspace, so instead of getting nice nested directory structure you expect, you get this flat list of workspace projects, and the same resources often present in multiple places, which confuses team providers, and the workspace is very hard to navigate, and so when you switch between USCM branches, you have to either add projects that aren't are new to the target branch, or remove projects that aren't present there. So it's not nice that there is no support for nested projects. And well, I guess this is it, right? So Maven and Eclipse, they provide significantly different execution environment for plugins and well, both Eclipse plugins and Maven plugins. So there are fundamental limitations in Eclipse Workspace that m2e simply cannot work around. Right, so we have to live with these limitations. And writing proper Eclipse builders and resource change listeners is very hard. And so if you have some ideas or additional questions, so please either find me in the corridor or better yet, email m2e devlist. Yes. Well, the question is whether there are better solutions to lack of multi-module support in Eclipse Workspace. I don't know. Ask Workspace team whether they are willing to change their ways. There is a bug that was opened, I think, in 2002 about this by CDT team at the time. And I believe at least one of the companies behind CDT, they chose to re-implement their own built infrastructure to deal with this. Any other questions? Yes? Yes? I looked at it. I didn't think it was applicable. If you think that this can be useful, please email m2e devlist with your proposals and we'll consider. Okay, so the question is why m2e development team didn't raise a bug against platform to add support for better support for nested folders. Sorry, not nested folders, nested projects. So the answer is that there is a bug already, right? And platform team chose not to react to that bug. And from my experience, and if you just look for Bugzilla entries that I've opened against GDT team or platform team, in general, they are ignored. So I just don't have the time to do the Bugzilla that nobody will pay attention to. Well, so we can continue this forever, really. So any other questions? Yes.
We have currently problems with SCM support. So if we check our project as Maven project, then we lose the connection to the SCM. Do you have heard from this issue, or do you have an idea where this is localized?
I haven't heard of this particular issue. I had complaints that checkout from SCM requires installation of additional software, what we call m2e providers or connectors. I can't remember the term. But once you've installed appropriate connection for your particular version control system, as far as I know, it all works. But if it doesn't, please provide a patch and we will consider it. Quality patch, I should add. Any other questions? All right, thank you very much for coming.